All right, so what we're going to look at is something called the slope of the tangent line. And you have looked at tangent lines before in geometry. So this example here is from geometry. So if you have this radius and this tangent line, they're perpendicular. And just to refresh your memory, a tangent line means it touches one time. So this is tangent to the circle. What we're going to look at in calculus is how to find the tangent line to a curve. So here's a parabola. This is the tangent line at that point. You could have a point over here and you could draw in the tangent line. So at this point P, here's the tangent line to this function. At this point P, here's the tangent line to this function. So I could, like I said, I could have another point here and I could draw in this tangent line there. The problem that we have is that tangent lines only touch one point. And we really, in order to find the equation of a line, we usually need 2 points, like you learned in algebra, where you would find the slope and then plug back in to find like y equals mx plus b. So the problem that we have is that tangent lines only have 1 point, and that's why we need limits and calculus in order to find those tangent lines. And that's what we're going to look at. So let's look this problem so that we can understand the difference between a secant and a tangent. So I have this curve here and I have 2 points on there, and I'm going to attempt to draw a line in between these 2 points. I don't know how well that's going to go, but pretend I drew a straight line between these 2 points. That did not go well at all. So this is a secant if it touches 2 times. So if you draw this line right here, it touches 2 times. That's called a secant line. And when I'm finding a secant line, I can use the regular slope formula. Oops, sorry. Secant line. So if I wanted to find the equation of that line, I would find the slope by taking y2, so 5 minus y1 over 2, or 5 minus 2 over x2, so 4 minus 1. So 5 minus 2 is 3 over 3, which is 1. So the slope of that secant line is 1. What we want is the tangent line, and that's a little bit different. What that means is I don't want any distance between these two. I want a point like maybe right here. What is the slope of this tangent line right here? And it looks like it could be parallel. It looks like it could be 1, but it's not always the case. And so what we've been working with, delta x limits, can help you find the slope of this tangent line. So I'm going to try to show that because you already know the process of doing the delta x limits. So I'm going to first try to show you what that looks like. So let me find my example. Okay, so I have this very rough picture here, and it's just a curve, some curve. And this point right here, I'm going to call this point just x, and the y value, instead of just calling it xy, I'm going to call it f of x. And then I have another point over here. And let's say that the distance between these 2 points, so the distance from here to here, is delta x. So that's the distance, the horizontal distance. So that means this point, instead of just being x, it would be x plus delta x. That would be the x value because I would go from x and I would add delta x. And then the y value would be the function at this point. So the function evaluated at x plus delta x. So what I need to do is to find the slope of those between those 2 points. So for my slope, I would take y2, which is f times x plus delta x, minus y2, or y1, so f of x, so y2 minus y1, all over x2, which is x plus delta x, minus x. And then if I simplify, I can't do anything in the numerator, but if you look at the denominator, it simplifies to just delta x because these would cancel. And that is the slope of the secant line But remember, I want the slope of the tangent line. So in order to make this secant line here a tangent, I want the distance, this delta x distance, to be 0. So I use a limit process, and I say the limit as delta x approaches 0, because I want this distance to be 0, so my secant line becomes a tangent line, is the limit as delta x approaches 0 of this function, of this slope, and this gives me a new function that will give you the slope of the tangent line. So we have done the algebra with this, and now we're going to use it to find the slope of a tangent line. And that's where that comes from. So again, this is a slope formula that gives you any function that'll give you the slope of the tangent line. So let's just try one. Let's say that we have f of x equals x squared. I'm just going to use the basic quadratic. And I want to know the slope of the tangent line when x is 3. So in order to find the slope when x is 3, I need to find the function that gives me the slope. So I'm going to use my delta x limit with this. So I'm going to have x plus delta x squared minus x squared all over delta x. I'm going to go through this a little quickly because we've done these. So this is x squared plus 2x delta x plus delta x squared minus x squared all over delta x. Then the x squareds cancel, and all of these have a delta x, so I can factor one out. So it's 2x plus delta x, and the limit as delta x approaches 0. So I plug 0 in. So the function that I get is 2x. So this is the function that will tell me the slope of the tangent line. So 2x tells me the slope of the tangent line. So now I want to know, what is the slope when x is 3? So when x is 3, I plug that in there, the slope would be 6. So quickly, I'm going to go to Desmos and show you what that looks like. So my function was x squared. So I'm going to put in x squared. Here we go. And we want the slope of the tangent line at 3. So 3 is right here. There's 3. Right there is 3. So if I draw a tangent line in there, the slope, that would be my tangent line. The slope there is 6. So if I go back to my work, we know the slope is 6. I could even find the equation of the line, because when x is 3, if I put 3 in here, y is 9. So my point on my parabola is 3, 9. So I could say, well, y equals 6x plus b. And I put 9 in here and 3 in here. So I get 9 equals 18 plus b, so negative 9. So I have y equals 6x minus 9. And that will give you a visual. Y equals 6x minus 9. Oops, that's a 6. That is the tangent line that we came up with. So what you're going to do today, the algebra and calculus you're going to do is not different. You are going to use the delta x to find some slopes, and maybe even some equations of lines. All right, so I know it's a little bit different, but remember the algebra is the same. You're just now understanding that that's a function that gives you slope after you find the limit.